Now see, now I'm giving to all of you. So today we discuss about what? Thermodynamics. Regarding that, first question. Say the first question. State state first law of thermodynamics. State first law of what? State the first law of the thermodynamics and write its mathematical relation. Write its mathematical relation. Right, Nana? First of all, how you define the statement of the first law of thermodynamics? See, the first law states that, simple statement, Nana, the first law states that energy of the process, energy of the given process, energy of the process neither created, energy of the process neither created nor destroyed, but change from one form to other form. But what I am saying, change from one form to other form. That is the statement. Repeat the statement once again, Nana. So what is the first law of thermodynamics? So the first law states that what? The first law states that energy of the process neither created nor destroyed, but changed from what? One form to other form. The same statement you write like this. How you write the same, students? The first law states that, the same statement you write like that. The first law states that energy of isolated system. What I am saying? Energy of the isolated system. What is the meaning of isolated system? The system have no contact with surroundings. What I am saying, Nana? The system have no contact with the surroundings. So the first law states that energy of the isolated system remains constant. What I am saying, Nana? The energy of the isolated system remains constant. This is the second statement of the first law. And anyone give the live example of the first law. So energy of the process neither created nor destroyed but changed from one form to other form. So what is the best example for the first law of thermodynamics? The best example is, so the light energy, what I am saying, Nana? The light energy converts to, the light energy converted to electrical energy without loss or without gain to the surroundings. Or you take like this. So electrical energy converted to light energy, better to write. Electrical energy converted to light energy, or light energy converted to electrical energy, one of the best example for the first law of the what? Thermodynamics. And we write the two statement like that and write the example. So better to feel the examiner happy. And next one. So what you write, Nana? So mathematical expression. So the mathematical expression of the first law is delta U is equal to Q into plus of minus W. This is the mathematical expression of what, Nana? JN. The mathematical expression of the first law of thermodynamics. Here, delta U means what? Abbreviation also important. Delta U means change in internal energy of the process. What I am saying? Change in internal energy of the process. That is delta U. And what is Q? Q means Q plus Q means what? Heat supplied to the system. Heat supplied to the process. Heat supplied to the process. That is Q. And W. Here W means what? Minus W is there. That is work done by the process. In chemistry, most of the cases work done by the gas on the surroundings. You write the abbreviations like this and the examiner perfectly say. Generally, JN, very good, Nana. Nice doubt, Nana. Generally, in the chemistry point of view, the work is pressure volume work. The gas have its own pressure, the gas have its own volume. So against the external pressure, the volume of the gas is expanded in most of the cases. So out of the 90% of the cases, the gas is released from the reaction. Gas released means what? Gas is expanded. That means work done by the gas is taken minus. Understood, Nana Jain? Yes. So this is the first law of thermodynamics. 4 marks question successfully completed. Right, Nana? And go to the next 4 marks question. State and explain the Hess law of the constant heat summation. What is the next question, Nana? State and explain. State and explain Hess law. Hess law of constant heat summation. Constant heat summation. Simple statement. Actually, it is the one of the beautiful question for the 4 marks. I think so. From the thermodynamics, maybe first line, it's a mathematical equation is given, or this one is given. State and explain the Hess law of the constant heat summation. So actually, now see, Hess law states that, what I am saying, Hess law states that heat change or enthalpy change, heat change of given reaction, heat change of what? Heat change of the given reaction in the single step, what I am saying, heat change in the given reaction, heat change of given reaction in the single step equal to the net heat change of multiple steps of what, Nana? Multiple steps. This is the statement of what? Hess law. Repeat the statement once again. Very good, Nana. Heat change of the given reaction, the single step equal to the net heat change of the multiple step. Therefore, it's the application of what? Application of the first law of thermodynamics. Application of first law. Application of the first law of the thermodynamics. Because in the thermodynamics also, energy neither be created nor be destroyed, but change from one form to another form without loss, without gain to the surroundings. Here also, heat change in the single step of the reaction is equal to net heat change of the multiple steps. That's why it is the application of what? First law of the thermodynamics. What I am saying? Application of what, Nana? First law of the thermodynamics. Understood what I am saying? Clear? Its application of what, brother? First law of thermodynamics. Now, for example, we take a one generalized reaction. A gas gives rise to B gas. Enthalpy change in the single step is equal to plus Q kilojoules. Now the same reaction converted to A gas to B gas. This is called delta H1 is equal to Q1. B gas to C gas. Tell me. B gas to C gas. Now it becomes what? Delta H2 is equal to Q2. Now C gas to B gas, delta H3 is equal to Q3. Therefore, heat change in the single step. Therefore, delta H with respect to A to B is equal to delta H of what? A to B plus delta H of what? B to C plus delta H of what? C to D. Therefore, so Q is equal Q1 plus Q2 plus Q3, you write like that. That is the Hess law of constant heat summation. Now, where this application, where the Hess law is applied. Now, discuss about applications of the Hess law. Here, applications is no need of the problem, just to write the applications. Applications of the Hess law. Now, generally, so the Hess law is applicable to calculate. So, the law applicable to calculate lattice energy of ionic compounds, lattice energy of ionic compounds by Born-Haber cycle is the first application. By what cycle, Nana? Born-Haber cycle. Born-Haber cycle is the first application. The law applicable to the calculate lattice energy of the ionic solids by Born-Haber cycle. Second one, the law applicable to calculate to calculate enthalpy formation of unstable molecules like enthalpy of formation of unstable molecules like actually the CO gas itself is unstable, the NO gas is itself is unstable, NO2 gas is itself is unstable. The law applicable to calculate enthalpy of formation of what? Enthalpy of formation of unstable molecules like CO gas, NO gas, NO2 gases. And the third application, the law applicable to the enthalpy of transition of allotropic forms. What I am saying? Enthalpy transition of what forms? Allotropic forms. What is the meaning of allotropic form? Rhombic sulfur to converted to monoclinic sulfur. Graphite is converted to what? Diamond converted to graphite, like that. So the law applicable for enthalpy change of transition of the allotropic forms. So these are the applications of S law. Repeat once again, students. So regarding applications, the law applicable to calculate what? Lattice energy of ionic solids by Born-Haber cycle. And the second application is what? The law applicable to calculate enthalpy of formation of the NO2 gas, enthalpy of formation of the CO gas, NO gas, because they are unstable molecules. The law applicable for enthalpy of transition of what? Allotropic forms. So the successful 4 marks question completed. And see next one. Explain the spontaneity of the process in terms of the delta G. One of the beautiful question. Explain spontaneity. Explain spontaneity of process. Explain spontaneity of the process in terms of delta G of reaction. Now here, simple logic I said. You know Gibbs equation. So according to Gibbs equation, according to the Gibbs equation. So what is Gibbs equation? Gibbs equation is delta G of the reaction is equal delta H of the reaction minus T into delta S total. This is called Gibbs equation. As per Gibbs equation is taken, delta H of the reaction is positive sign. Positive sign means what? Endothermic nature is given. Delta S of the reaction, negative sign given. Negative sign means what? Randomness decreases. What decreases, Nana? Randomness decreases given. Then you substitute that delta G. That is given in the textbook, Nana. The table is given in the textbook. Delta H of reaction is right like that. Positive sign means endothermic nature. Delta S of reaction is negative sign means randomness decreases. Therefore, delta G of the reaction is equal. So delta H minus T into delta S. Delta H is what sign? Positive sign minus T into delta S is what sign, Nana? Negative sign. Right, Nana? Now what you write, brother? That becomes, this is positive side. Minus into minus is what? Positive sign at temperature given. Positive means what? The positive means more positive. That's why at all temperatures it is non-spontaneous process. At all temperatures of reaction. At all temperatures of the reaction. Nana, Gibbs energy means what? Free energy available in the gas that is converted to useful work done by the gas. Nana, Chandrakala, free energy, Gibbs energy means what? Free energy available in the gas that is converted to useful work done by the gas. Understood, Nana, Chandrakala, in a single word? Nice, in one word, yes. At all temperatures of the reaction, the process non-spontaneous nature. The process is what nature? Non-spontaneous. The process is non-spontaneous nature. Understood what I am saying, Nana? So the first one is completed, right? See, delta H of reaction is positive means endothermic. Delta S of reaction is negative means randomness decreases. So minus into minus, positive, positive, positive becomes more positive. Therefore, at all temperatures, the process becomes non-spontaneous nature. Understood? So the first one is completed. And come to the next one, Anna. Delta H of the reaction is what sign? Negative sign. Negative sign means what, Anna? Negative sign means exothermic nature, right? And delta S of reaction is what? Delta S of reaction is positive side. Positive side means what? Randomness increases. What is randomness? Zigzag movement. Randomness in the gas molecules increases. Delta S of reaction positive side means what? Randomness in the molecules increases. Now substitute in the Gibbs equation. So what you get into the delta G of the process? Tell me. Delta G of the process. Delta H minus T into delta S. So delta H is what sign? Negative sign. Minus T into delta S is what sign? Positive sign. Plus into minus is what? Minus. This is negative sign. This is negative sign at given temperature. Positive negative is what? Negative. At given temperature. Now negative negative means what? Negative negative means more negative sign. That means delta G more negative means what? The process is spontaneous at all temperatures. Therefore, the chemical reaction or chemical process. Therefore, the chemical process spontaneous. The chemical process spontaneous at all temperatures. Understood, Nana? What I am saying? The chemical process is spontaneous at all temperatures. Why the chemical process is spontaneous at all temperatures? Because delta G is more negative at given temperature. That's why the chemical process is spontaneous at all temperatures. All temperatures means what? Maybe low temperature, maybe high temperature, maybe medium temperature. Simple logic. Understood what I am saying? Right? And see the next one, Nana. This is but very important, Nana. So delta H of the reaction is negative sign. Negative means what? Exothermic nature. And delta S of the process or delta S of the total is negative sign. Negative sign means what? Randomness decreases. What I am saying, Nana? Randomness decreases. And substitute in the equation. When substitute in the equation, what you get? Delta G of the reaction is equal. So negative sign minus T into negative sign. Yes, you know very well negative sign, this value, and this is what sign? Positive sign at temperature T. Understood, Nana? Nana, max class are not explained, Nana. Chandrakala, max class are not explained. Okay, I said to the sir, don't worry. Now, negative sign, minus into minus is what sign? Positive sign. Now, check the point here. Delta G is negative. Delta G of reaction is negative. That is what? Delta G of reaction is a negative sign. That is spontaneous. Delta G of reaction negative means what? Spontaneous. How you get spontaneous? See, Nana, here negative sign belongs to what? Negative sign belongs to delta H. Positive sign belongs to what? T delta S. Understood what I am saying? So delta G of reaction negative sign, now it is the reaction is spontaneous. Now based on that, delta H should be greater than T into delta S. From that, delta H by delta S value should be greater than given temperature. That means your given temperature should be low temperature. Therefore, at lower given temperature, what I am saying? At lower given temperature, the chemical process is spontaneous. That means the chemical process is what, Nana? The chemical process is spontaneous. Understood what I am saying? at lower given temperature, the chemical process is what? Spontaneous. Understood what I am saying? Simple logic, no confusion. Because negative sign belongs to delta H. Positive sign belongs to what? T delta S. Jayant, what is the doubt? Sir, can you tell the equation again? Array brother, what is the equation brother? Delta G is equal to delta H minus T into delta S. This is the equation brother. See, delta H value given what? Negative side. Delta S value given what? Negative side. Negative into negative is what side? Positive side. Delta G is negative, that is a spontaneous. That's why delta H should be greater than T delta S. Therefore, delta H by delta S should be greater than given temperature. So therefore, the given temperature should be lower. Lower given temperature, the chemical process is what? The chemical process is spontaneous. Understood, Nana Jane? Nice. And see the next point. Clear what I am saying? Understood what I am saying, Nana? Yes. Now, the last point, Tamru. Delta H of reaction is what sign? Delta H of reaction is positive sign. Positive sign means what? Endothermic nature, right? And delta S of the reaction. Delta S of reaction given as positive sign. Positive sign means what? Randomness increases. Randomness, what happens? Randomness increases. Then thou substitute in the formula. Now you get delta G of the process is equal delta H minus T into delta S. Right, Nana? Now delta H is what? Positive sign minus T into delta S is what sign? Positive sign. Now this is positive sign, this is a negative sign at given temperature. Understood what I am saying? Now you want to make, now here simple logic, delta G of the process is negative sign, that is spontaneous. Now delta G of the process is a negative sign. Now that is an what? That is an spontaneous process. What process? Spontaneous. That means reaction moves on its own. Therefore here T delta S value should be greater than what? Delta H. Then only delta G of the process is negative sign. From that, delta H by delta S should be less than given temperature. That means the given temperature should be high temperature required. Or given temperature should be what? High temperature is required. Understood what I am saying? The given temperature should be what required, Nana? High temperature required. Simple logic, no confusion in the logics. No confusion in the logics. So this is the spontaneity of the reaction in terms of delta G. Yes, the same explanation is given, Nana. The same explanation is also important for the objective point of view also. What point of view? Objective point of view. And say next question. State in second law of thermodynamics, explain it. Yes, Nana? Explain. State and explain the second law. State and explain the second law of thermodynamics. Now regarding second law of what? Thermodynamics explanation. How you explain? Simple logic. Regarding second law of thermodynamics, see the first statement, statement 1. All natural processes are thermodynamically, all natural processes are thermodynamically what nature? Thermodynamically irreversible nature is the first statement. Understand once again? All natural processes are thermodynamically irreversible nature. Understood, Nana? Very good. And come to the second statement. So, in irreversible process, where delta G of the process, minimized, and delta S of the process should be increased. Second statement should be what? Increased. Increase means what? Randomness is increased. In either process where delta G of the process is minimized, delta S of the process should be maximized. Maximized means what? Increased. And see the third statement. Third statement is what? Heat transferred from hot body to cold body, heat transfer from hot body to cold body with the loss or gain to the surroundings, loss or gain to the surroundings. What I am saying? Heat transfer from hot body to cold body. What I am saying? Heat transfer from hot body to cold body with the loss or gain to the surroundings. Understood, Nana? And see the next statement, the last statement. Each statement is the fourth mark question. Each statement has 1 mark. What is the fourth statement? Efficiency of the Carnot heat engine. What I am saying? Efficiency of the heat engine always less than 1. What I am saying, Nana? Efficiency of the Carnot heat engine always less than 1. So these are the statements of what? Second law of thermodynamics. And come to the next one. What is entropy? Explained with examples. Simple logic one. What is entropy? Explained with examples. Simple statement of entropy. So how can you explain the concept of this entropy? Entropy is defined as, see the simple statement, entropy defined as randomness of molecules or zigzag movement of the molecules. Randomness of the molecules present in the gas. Simple statement. Randomness of the molecules. What I am saying, Nana? Randomness of the molecules present in the gas is called entropy. Understood what I am saying? Randomness of the molecules present in the gas is known as what? Is known as entropy. Understood? Now, here, therefore, delta S of the process is equal, what you write? Q reversible by T you write. That means, so Q reversible by T means what? At low temperature, change in entropy. What I am saying, Nana? At low temperature, so change of entropy of the process more observed, change in entropy of the process more observed than heat supplied to the gas at high temperature. To the gas at what, Nana? High temperature. The reason is what? Because delta S is inversely proportional to temperature. That means what I am saying, Nana? At low temperature, delta S of the process is more observed than heat supplied to the gas at high temperature. Because of the at given temperature, delta S is inversely proportional to temperature. Heat supplied to the change of entropy of the process more observed at low temperature than at high temperature. Understood what I am saying, Nana? Yes, very good, Nana. Now, explain with the examples. So, what are the examples of the entropy? Here, best example. First example, delta S of the given solid less than delta S of the liquid. Delta S of the liquid less than delta S of the gas. First example completed. And come to the second example. Evaporation of water. What I am saying, Nana? Yes. Okay, no problem, Jashwant, no problem, Jashwant Kumar. Yeah, no problem is the best objective instrument, Nana, no problem with that. And see next one, evaporation. Evaporation of water. Evaporation of water from the lake. Evaporation of water from the lake in summer season. What season? In summer season, one of the best example of the what? Example of the entropy, because the liquid of the water changes to gaseous form. Na? Second example. And third example, na, melting of ice. So ice is a solid. Solid of the ice on melting, you get the water. And fourth example, na, fourth example, burning of the candle by consumption of the wax. By what? Consumption. By consumption of the wax. You know wax? So when candle burning, the wax is completely consuming happens. Understood, Nana? And the fifth example, Nana? And the fifth example, see, dissolution of the ionic solids. What I am saying, brother? That call to the Roots Academy number is there, na? So on the online Roots Academy number is there, 986691. You call to that numbers, na? Zain, Jashwant, you call to that numbers. Okay? Dissolution of the ionic solids. Dissolution of the ionic solids in the aqueous solution where the entropy increases. Why? The ionic solids may be exothermically soluble or endothermically soluble. Simple logic. Dissolution of the ionic solids in the aqueous solution. Right, Nana? And so these are some examples. So many examples are there. These are very important some of the examples. Understood what I am saying, Nana? Yes. Yeah, one more example. Dissociation of the gases also entropy increases. So 2 moles of the ammonia on platinum surface, dissociation happens, you get what? You get N2 gas plus 3H2 gas. Here, delta N of the gaseous state is equal to 4 minus 2, that is equal to plus 2. Where delta N is plus 2, delta S is what sign? Delta S is a positive sign. So this is the example. So examples repeat once again. The first example is what, Nana? Evaporation of the water from the lake in summer season. Second example, melting of the ice. Third example, so burning of the candle by consumption of the wax. Dissolution of the ionic solids in the aqueous solution. The dissolution may be endothermic or exothermic. The solids are decomposing into aqueous cations and aqueous anions. Dissociation of gases where delta N is positive, delta S is positive sign. Like that examples. You have the 4 marks. State and third law of thermodynamics, what do you understand by it? Is given in the previous paper. Now, 2 marks question is given. State and explain third law of thermodynamics. For the 2 marks question is given. Third law of thermodynamics. Simple statement, Nana. At 0 kelvins, what is 0, Nana? Minus 273 degrees. At 0 kelvins, the entropy of pure crystalline solids, what I am saying, the entropy of the pure crystalline solids taken as 0 because of sequential arrangement of, what I am saying, Nana? Sequential, because of the sequential arrangement of the particles. Sequential arrangement of the particles in the solids. Sequential arrangement of the particles in the given solid. Sequential arrangement of the particles in the given solid is called what? Third law of thermodynamics. Repeat the statement once again, Nana. What I am saying? At 0 kelvins. What is 0 kelvins? Minus 273. What is minus 273, Nana? Simple logic, Nana. So the entropy of the pure crystalline solid is taken as 0 because of what? Sequential arrangement of the particles in the solid. If the particles are sequentially arranged, so the entropy of the pure crystalline solids are taken as the 0 sign. Simple logic. That is the meaning of the law of thermodynamics. It is only given as a very short answer. Yes, Nana? Next, see the next question. Define heat capacity. What are CP, CV? Show that CP minus CV is equal to R. See the next 4 marks question, Nana. What is heat capacity? See the question carefully. What is heat capacity? Derive Cp minus Cv is equal to R. Simple statement. Nana. So how you define the heat capacity? Simple statement. So heat capacity defined as amount of heat supplied to the system. System means a chemical reaction. Are Nana? System means what, Nana? A chemical reaction. A chemical reaction taken as system or a gas is taken as a system. Amount of heat supplied to the system, that means a chemical reaction, to rise its temperature, by 1 degree, Nana. That's the simple statement of heat capacity. Repeat the statement once again, Nana. See, amount of heat supplied to the system. System means what? A chemical reaction to rise its temperature by 1 degree. That's the meaning of what? Heat capacity. Understood what I am saying? Now, how you derive the Cp minus Cv is equal to R. That is the simple derivation, easy derivation. How can you derive, Nana? You know, enthalpy. Enthalpy is equal to internal energy plus work form of energy. Now, here enthalpy change, dH is equal to internal energy change. For 1 mole of the gas I taken, Nana. Arey Nana, what I am taken? For 1 mole of the gas. For 1 mole of gas, what you write? P into dV is equal to D into RT. Okay, because PV is equal to nRT, na? In the PV equal to nRT per 1 mole of gas, P into dV is equal to what you write? So you write P into dV. Okay, right. From that, what you write? dH is equal to dE plus D into RT you write. D means what? Differentiation factor. R is a gas constant. Gas constant and differentiation, again you get a gas constant, because R itself is a constant. Constant and differentiation you get constant. Now dH is equal to dE plus R into dt. Right now, both sides divided by dt. Both sides divided by dt factor. So both sides divided by dt factor. Now what you come across? dH is equal dE plus R into dt by dt by dt by dt. dt cancel. Okay, dH by dt at constant pressure is called Cp. dE by dt at constant volume is called Cv plus R. That is derivation. Simple derivation. dH by dt at constant pressure is called Cp. dE by dt at constant value is called Cv plus R. Therefore, Cp minus Cv is equal to R. In derivation, the R value taken as calorie, that is 2 calories per mole. What is taken, Nana? 2 calories per mole. Understood? So this is the heat capacity and derivation between Cp minus Cv is equal to R. Easy, Nana. And see next one. What is enthalpy of reaction? Explain the standard enthalpy of reaction. See, what is the question given? What is the enthalpy of reaction? Explain standard enthalpy of reaction. Standard enthalpy of reaction. Simple, Nana. A small difference is there. enthalpy of the reaction. Clear what I am saying, Nana? Enthalpy reaction, standard enthalpy of reaction. Simple statement. See, enthalpy of reaction. Delta H of reaction defined as heat change observed. What I am saying, Nana? Heat change observed in the given reaction. Heat change observed in the given chemical reaction. What I am saying, heat change observed in the given chemical reaction is called enthalpy change of reaction. That means N2 gas plus 3H2 gas gives rise to 2NH3 gas. Heat change of the reaction observed as minus 46 kilocalorie. This is the enthalpy change of the reaction. What is standard? Standard means not. What is standard? Standard means not. Now, standard enthalpy change of reaction means heat change observed, tell me, heat change observed in the chemical reaction, heat change observed in the chemical reaction from the reacting species which are present in the standard state. Which are present in the what state, Nana? Standard states. What is standard state? At room temperature, room pressure. Room temperature is 25 degrees, room pressure is 1 bar pressure. Both have the same meaning. A small difference is there. Not means what, Nana? Not means standard. Standard means what? Heat change observed in the chemical reaction from the reacting species which are present in the standard state. What is standard state? Room temperature, room pressure. What is standard state, Nana? Room temperature, room pressure. Simple logic, no confusion in the logic. That is the meaning of standard enthalpy change of reaction. So, enthalpy change of reaction means heat change observed in the given chemical reaction at any temperature, any pressure. But standard means what? The reacting species are taken in the room temperature and room pressure. That is a small difference, Nana. Indicated by the not. Not means standard. And see next one, Nana. What is the standard enthalpy formation? Explain with example. What is, see the question, what is standard enthalpy of the formation? Explain with example. Explain with example. Simple statement. What is standard enthalpy of formation? Explain with example. Simple logic I said here, right? Standard enthalpy of formation defined as 1 mole of compound, 1 mole of the compound or molecule, because it's a compound, is the same meaning of the molecule. 1 mole of the compound or molecule formed from its constituent elements. From its what, Nana? Constituent elements at 1 bar pressure and 25 degrees temperature. Simple statement. Standard enthalpy of formation is defined as 1 mole of the compound or molecule formed from its constituent elements at 1 bar pressure 25 degrees Celsius. That is the meaning of standard enthalpy of the formation. Simple example. We take the example of H2O liquid. At room temperature, room pressure, H2O exists as liquid. H2O liquid formed from its elements H2 gas plus half O2 gas. In formation of the 1 mole of H2O, 1 mole of the molecule, amount of heat liberated or absorbed. Here delta H standard enthalpy formation of the water is minus 286 kilojoules per mole. Is exact value, not rough value, Nana. Exact value, Nana. Understood what I am saying? May be heat liberated or heat absorbed. Maybe what? heat liberated or heat absorbed. Understood what I am saying? That is the meaning of standard enthalpy of the formation. No confusion in the explanation, Anna. Easy explanation. Repeat once again, Anna. 1 mole of the compound or molecule formed from its elements at room temperature, room pressure, may be heat liberated, may be heat absorbed. If heat is liberated, the formed molecule is more stable. If heat is absorbed, the formed molecule is unstable. If heat is absorbed, the formed molecule is what, Anna? Unstable. For example, so N2 gas plus half N2 gas plus half O2 gas gives rise to 1 mole of the NO gas is forming from its constituent. Standard enthalpy of formation of the NO gas is what? So this is plus 200 kilojoules per mole. That means amount of energy absorption happens. Understood? That is the statement, Anna. You write like that, you get full marks. Examiner is highly impressed. Examiner is highly impressed, Anna. And see next one. Define and explain enthalpy of the combustion. Define and explain what? Enthalpy of combustion. That is very easy, Anna. So, enthalpy of combustion. How you define the enthalpy of combustion? Simple statement. Heat liberated, what I am saying, Anna? Heat liberated when 1 mole of the molecule, 1 mole of the compound or 1 mole of the molecule burnt in excess oxygen. What I am saying now, what is the enthalpy change of combustion? Heat liberated, 1 mole of the molecule burnt in excess oxygen, comma, it's always exothermic nature. What is the meaning of exothermic? Amount of heat liberated. It's always exothermic nature. It's always exothermic nature. Understood what I am saying? One of the beautiful point. Repeat once again. Heat liberated when 1 mole of the molecule burnt in excess oxygen is always exothermic nature. Understood what I am saying? Here, so enthalpy change of combustion. What I am saying, Anna? Enthalpy change of combustion is a kind of redox reaction. Kind of what reaction, Anna? A kind of redox reaction. In redox reaction, half part is oxidized and half part is reduced. Enthalpy of combustion is a kind of redox reaction. Understood what I am saying? Simple logic, no confusion in the explanation. Right, brothers? So 1 mole of here combustion is always exothermic reaction. So here heat is liberated. What I am saying? Heat is liberated when 1 mole of the molecule burned in excess oxygen. Always exothermic nature is a kind of a redox reaction. Understood what I am saying? Enthalpy combustion is a kind of redox reaction. Very easy explanation, no confusion of the explanation. Right, Nana? And one more important point, right? Enthalpy of combustion data, enthalpy of combustion of the molecules, enthalpy of the combustion of the molecules, okay, determined from the bomb calorimeter instrument. From which calorimeter? From bomb calorimeter. So the enthalpy combustion molecule is determined from the using of what? Bomb calorimeter. This is the simple statement and no confusion. And this is 4 marks questions are over and some examples are over. And come to the 2 marks questions now. So what is define a system? That is not important. Now see, this is a very important question. No heat is absorbed by the system from surroundings, but work is done on the system. What type of the work does system have? Take system means what? Nana? Yes. Jayan, what you said, Nana? I observed there is only small changes in physics thermodynamics. No. Chemistry thermodynamics is 100% different from the physics, Nana. In the physics, derivation part is there, but in chemistry there is a chemical reactions. The thermodynamics linked to the chemistry of the chemical reaction, but physics is the sub part, only the small difference. But the remaining part is highly different. With respect to chemistry, we discuss about all the thermodynamic principles are applicable to the chemical reactions. Right, Nana? See the 2 marks question. No heat is absorbed. What is the first law of thermodynamics? So delta U is equal to Q plus of minus W. No heat is exchanged. No heat is exchanged to system gamma surrounding. That is called what? Adiabatic process. What process, Nana? So in adiabatic process, what is adiabatic process? No exchange of heat between system gamma surroundings. Now therefore delta U of the process is equal to what you write? Minus W. Understood? Delta U of the process is what, Nana? Minus W. Therefore, from that, so this is a what kind of a wall? Thermally insulated walls are taken. What taken? Thermally insulated walls are taken. This is the simple statement I write here. Thermally insulated walls are taken. Now, by using of this thermally insulated walls are taken, no exchange of the heat between system gamma surroundings. Therefore, delta U of the process is equal to minus W, because the walls are thermally insulated are taken. Therefore, what type of wall is taken? Thermally insulated wall is taken. And state in the first law are given. What are the intensive properties and the extensive properties? See, intensive property means what? Intensive property means the thermodynamic property of the system. What I am saying now? The thermodynamic property. The thermodynamic property of a system not depends on the amount of the substance present in the system. Not depends on amount of the substance. Not depends on the amount of the substance present in the system. Simple statement. What is the statement I said? The thermodynamic property of a system not depends on the amount of the substance present in the system. It's called intensive property. So what are the examples of intensive property? Temperature is an intensive property. Melting point is intensive property. Boiling point is intensive property. Pressure is intensive property. Concentration. What is concentration? Capital M, capital N, small m, mole fraction. So all are examples of intensive properties. Understood, Nana? So this is examples of intensive property. And come to the extensive property. Now regarding extensive property taken. Now regarding the extensive property. What is extensive property? The thermodynamic property of the system. The thermodynamic property of a system. The thermodynamic property of the system depends on the amount of the substance present in the system. Simple statement. What I mean by this statement? The thermodynamic property of the system depends on the amount of the substance present in the system. So one of the best example is what? One of the best example, mass, volume, area, right? Number of moles. What I am saying? Number of moles. Other examples of what? Number of moles. Other examples of what? So this one. Yes, Nana. Yes, okay, Nana. Jashwan Kumar. Okay, no problem, Nana. Nice, no problem, Nana. So mass, volume, area, number of moles taken as examples of what? Enthalpy. Tell me. Enthalpy, internal energy. Tell me. Internal energy, right? And OB, they are examples of what? Extensive properties. Clear? So the examples are successfully completed. And see the next one, Nana. So give the equation that gives relationship between delta H comma delta U. Next one, relationship between what? Delta H comma delta U. That is nothing but enthalpy. delta H of the process, enthalpy change of the process is equal to summation of what? Summation of internal energy change and the work form of energy. What energy, Nana? Work form of energy. Therefore, from that delta H of the process, summation of energy means what? Delta E plus work form means what? P into delta V. And according to the gas equation, you know, brother, P into delta V is equal delta N in the gas state into RT. Now what you write? Therefore, delta S of the process is equal to delta E of the process plus delta N in the gas state into RT. Now, delta N gas state means what you write? NP in the gas state minus NR in the gas state, you write like that. So, this is the important 2 marks question. So, next one, increase of entropy is the criteria for spontaneously why? So, increase of the entropy is the criteria for spontaneous nature why? Yes, Nana. So, in all natural process, see, increase in entropy criteria for spontaneous nature. That's the question given. Spontaneous nature. Increase of entropy is the criteria for spontaneous nature. That is the question given. Why? Simple logic. So in all natural thermodynamic process, entropy of the system increased. For example, Nana, wind moving from high region to low region. So the wind gas molecules are randomly moving. Understood? So the water falling from high altitude to low altitude. The water falling from high altitude to low altitude. So the water molecules, some water molecules are vaporized. Some molecules are what? Vaporized. That's why in all natural thermodynamic process, the randomness of the molecules increases. In all thermodynamic natural process, the randomness of the molecules increases means what? So the spontaneous nature is there because all natural thermodynamic processes are spontaneous nature where the entropy of the process increases. Understood what I am saying? And one more thing, in the given chemical reaction, delta N in the gas state is greater than 0, entropy increases. In the given chemical reaction, delta N in gas state less than 0, entropy decreases like that. Like that. Understood what I am saying? Simple logics, no confusion in the logics. Very easy logic. Yes. Next, explain relation between Gibbs energy change and equilibrium constant. Relation between Gibbs energy change and equilibrium constant. Yes, Nana? Delta G is equal to delta G naught plus 2.03 RT log to the base 10 QC. Yes, yes. At equilibrium of reaction, at equilibrium of the process, what I am saying, at equilibrium of the process, QC is equal to KC, right? At equilibrium of the process, delta G of the reaction is equal to 0. Now, based on that, so delta G 0 is equal to delta G naught plus 2.303 RT log to the base 10 Kc. So from that, delta G naught of the process is equal to what you write minus 2.03 RT log to the base 10 Kc. So this is the important relation between delta G naught of the process with respect to equilibrium constant of the reaction. Easy, Nana? What I am saying now? Main equation, delta G of the reaction is equal to delta G naught of the reaction plus 2.03 RT log to the base 10 QC. Yes, at equilibrium of the process you are very well known. QC is equal to KC. Yes, at equilibrium delta G Gibbs change of the reaction is what? 0. And substitute 0 there, that plus 2.0 becomes this side, you get become minus 2.03 RT log to the base 10 Kc. Therefore, delta G naught of the process is equal to minus 2.03 RT log to the base 10 QC. That is relation between delta G naught of the reaction and what? Kc. This is your today's class. Tomorrow discuss about hydrogen and its compounds. Tomorrow morning, here we have the class, Nana. Right.